Today we'll do another example of limits. We started with direct substitution, which is always a go-to method of calculating limits given a function. But sometimes things get weird, like when you're dividing by 0. And to avoid that, we need to try some other tricks. One of the tricks last time was factoring. Today we'll learn something else, and that is known as multiplying by the conjugate. So let's try that example. Let's find the limit as t approaches 0. And funny thing with calculus and limits is you can insert any letter. We usually use x, but if you do t, don't get phased by it. It's the same process. T squared plus 9 minus 3 all over t squared. Now, mental check 1. If you do direct substitution, what would you have gotten? You would have gotten square root of 0 squared, which is 0, plus 9 minus 3 over 0 squared. Square root of 9 is 3. 3 minus 3 is 0, so we would get 0 over 0. Again, this is undefined on the denominator. So we have to try something else. So question 1 was, can we factor this? Well, last time we learned that we could factor it, but in this case, square root of t squared plus 9 cannot be factored. So this is why we use method 2. So what does it mean to multiply by a conjugate? I have said this big term. Now let's try to do this. So limit as t approaches 0, square root of t squared plus 9 minus 3 times t squared. The idea is that we want to get rid of the square root. So how do we get rid of the square root? Well, by multiplying by the square root again. So the trick here is we multiply by square root of t squared plus 9, but instead of a minus 3 now, I will do a plus 3. So we are using opposite signs and taking advantage of difference of 2 squared. But can I randomly multiply any fraction by any other term? No. We can only do that if we are multiplying by the top and bottom by the same term. Right? This in essence means we're multiplying by 1, which is okay. So now let's see what we have. We have the limit as t approaches 0. Well, square root of t squared plus 9 times square root of t squared plus 9. Now the square root goes away. That is just t squared plus 9. And what will happen is, let me do this on the side. When you multiply the other terms, we'll get 3 times square root of t squared plus 9 minus 3 times t squared plus 9. Right? And they will cancel. So you will only be left with t squared plus 9 times this negative 3 times positive 3, which is a minus 9. And the denominator, now we'll have this big ugly thing, t squared times the square root of parentheses square root of t squared plus 9 plus 3. Now before we plug in the limit, we can make some simplification. Plus 9 and minus 9 cancels. So we have the limit as t goes to 0, t squared over t squared times square root of t squared plus 9 plus 3. But are we done? The answer is no, because if we just plug 0 in the denominator, we'll still get 0. So what do we notice? Aha! Both the numerator and denominator has t squared, so we can cancel that. We're left with the limit as t approaches 0 of 1 over square root of t squared plus 9 plus 3. And now it's time to do direct substitution. Wherever I see a t, I'll plug in a 0. So I'll get, and same thing, so limits, we can add, we can multiply, we can divide, we can also put the limit inside the square root. So direct substitution works here as well. We will get 1 over 0 plus 9 is just square root of 9, which is 3, plus 3, so the limit is actually equal to 1/6. And that's it. That's the example for today.